Okay, so what I've done is I've actually opened another window with the lab, with the simulation next to it, and I have the lab on the other side. So it makes it a little bit easier to see the questions as I'm doing the simulations. So this should work while you're on a computer, but it may not. It'll be difficult to do this on a tablet or an iPad. Um, so once you've going back to the lab, once you've clicked it and it's opened here, um, you're gonna again highlight the variables that you can change in this simulation. So um, you can drag. So what are some of the things that you can change? You're gonna highlight those. Um, the next thing that you're going to do is the third question is, what do you think the size of the black arrows on top of the spheres represent? So these arrows right here, what do you think they represent? And remember, we're looking at, this is a force of gravity lab. So keeping that in mind, what do you think these arrows represent? When you move the spheres back and forth, you'll notice that that's the number of change. So that letter N is a unit. N stands for Newton, and Newton is a unit of force. So with that in mind, what do you think these arrows are representing? Once you're done with that, the next thing that we're going to do is do the actual lab. So I put together an example for you. In the example, the direction says pick a variable to manipulate and summarize what you changed and what happened in the table below. So I put a question: what will happen to the force of gravity if I keep the size of the spheres the same but change the distance between them? So my independent variable will be the the distance between the spheres, and my dependent variable will be the force of gravity. So the force of gravity on each of the spheres. Um, so my observations is that starting out, I see that I'm going to click right here where my spheres are the same size. The mass of sphere 1 is 2 billion kilograms, and the mass of sphere 2 is 4 billion kilograms, and my starting distance is 4. And I've also noted that the force of gravity, since we learned up here, you exert the same force, gravitational force on the Earth as it does on you. So these guys will exert the same gravitational force on each other. And so I note that that is 33.4 newtons. So that's the force of gravity, or the gravitational force of each sphere on the other. So the next thing that I'm going to do is I'm going to move this to 8 kilometers. And I'm going to make note of what's changed. So I started off with my force of gravity being 33.4 newtons, and now it's gone down to 8.3 newtons at when I move the spheres to 8 kilometers apart. So I'm going to record that all in my over here, and then I'm going to go back up here, and I'm going to say, as the distance between the two figures increased, the force of gravity on each of them decreased, right? Because I saw when I had them close together, the force was 33.4 newtons, and as I moved them apart to 8 kilometers, it was 8.3 newtons. So the only thing that I'm changing is the distance, and as I change the distance, this force is decreasing. So my conclusion is that if I keep the spheres, the size of the spheres the same, but increase the distance between them, the force of gravity will decrease. This means that the greater the distance between two objects, the smaller the force of gravity will be, right? And you can keep going. If I keep pulling this apart, you'll notice that the force of gravity will continue to decrease.